Okay, boys and girls, let's get started. Hello, hello. Hands-on model fractions of multiplication, chapter 9, lesson 8. How can I use operations to model real-world fractions? 3 warehouses had a total of 2,844 cans of paint. Suppose each warehouse had the same number of paint cans. How many cans of paint were at 2 of the 3 warehouses? Go ahead and do your problem of the day. Okay, let's do it. So we're going to divide 2,844 by 3. 3 can't go into 2, so we have to go to 28. 3 times what comes close to 28? 3 times 9, which is 27. Do our subtraction. Bring down our 4. 3 times what comes close to 14? 3 times 4, which is 12. I got to bring this up over here. So I'm going to subtract, and I'm going to bring over my 4. 3 times what comes close to 24? I know that 3 times 8 is 24. So now I'm going to just do this. So we know that at each of the locations, there's 3 locations. Each location had 948 cans of paint. Oops. They want to know how many were in this location, in these 2 locations. So you could do 948 times 2. Get your 16, carry your 1, you get 9, 18. The dog just came back from a walk. 1,896. So they want to know how many were at 2 of the 3, and that would be this answer, 1,896. There we go. Oh, are you going to do this to me today? Oh, you know I hate when that happens. Okay. No, it's going to do this. All right, hold on. Agnes is yelling at her technology too. Come on. No, I'm not going to make you do the problem of the day over. I'm just going to wait for this to load. Okay. All right. So the first thing that I'm going to do is talk about unit fractions. Remember, unit fraction always has 1 as its numerator. A unit fraction always has 1 as its numerator. Okay? Always has 1 as its numerator. A unit fraction always has 1 as its numerator. So it's telling you, if we were in class, I would be giving you guys fraction tiles, but we can't because we're not in school. But it says model 4/5 using fraction tiles. So what we would do is you would put out 4 1/5 fraction tiles. Because we only add our numerators, right? Our denominator never changes. It always stays the same. Okay, so we did that. So we used 4 fraction tiles. Oh, come on. Oops. It's annoying. Why is it doing this? No, it's still bringing me back to the same one. All right, let's... Wow. Okay, hold on. Sorry. This is like... I guess they're having a problem with their site today. Okay. So basically what we did is we took our 1/5 and we added it 1/5 plus 1/5 plus 1/5 plus 1/5. Now remember that multiplication is repeated addition, okay? So basically what you did was you took, when we did the 4/5, you said, yeah, I know how many fraction tiles. I'll do 4 fraction tiles times 1/5. 4 times 1 equals 4. What doesn't change? The denominator. Here's what I want you to know. When you multiply a whole number by a fraction, you multiply the whole number by the numerator, and then you put your numerator in its new spot, and you leave the denominator alone. Do not touch the denominator. That's the thing that doesn't change, okay? So when we do the rest of the lesson, I'm going to do it that way. See, I had already done this. But I did it and you guys couldn't hear me. So I had to erase that one. Okay, so use an equation to write 2 times 4/5 as a multiple of a unit fraction. So here's what I'm going to do. I'm going to walk you through this. So it says add like fractions. I'm not going to do that. Here's what you're going to do. You're going to say 2 times 4 is 8 over what doesn't change? The denominator. Now they said make it a multiple of a unit fraction. So that's where I'm going to take my 8, bring it down, times 1/5. Because if I had you do this with fraction tiles, you would have put out 8 1/5 fraction tiles. Okay? So it's 8 times 1/5. That's all. Okay? I'll do a couple more because I know it's going to seem like, what? So, write an equation showing how 3/8 is a multiple of 1/8. This is what they want. Take your numerator, make it a whole number, times your fraction. Because you multiply your whole number times your numerator, which gives you this numerator, and the 8 doesn't change, okay? It's not like a mixed number. This isn't a mixed number. A mixed number means that you have 3 and 1/8 all together. This isn't what they're saying. They're saying take a 1/8 tile and stack it up. How many do you have? 3. 3/8, okay? It's different than a mixed number. All right, so I'm going to do this, right? Equations, and I got to make sure that I'm not infringing on your, okay, so to try it, it looks like this is what you're supposed to do. Oh, no, okay, I can still do this. Gotcha. Write equations showing how 6/8 is a multiple of both 3/8 and 1/8. Okay. So, where is this in my book? This is talk about it. This doesn't make any sense. You know, I get very frustrated with this math book sometimes. I'm going to skip this one. Okay, 6/8, 6. Oh, duh. I should have figured that one out. Well, I was dumb for not doing that. So look, I would never make you do this, by the way, but that's what they were saying for that one. And I'm going to give you a second to look at it, but I wouldn't ask you to do that. All right. Practice it. I'm going to do a couple of these because I don't want you getting confused. All right, so first I'm going to do number 3 with you and number 8, okay? So number 3, these are pretty easy. You just take your numerator, you say 3, make it a whole number, times 1/4. That's it, okay? Easy, right? Now number 8, this is what you're going to do. First, multiply your whole number times your numerator, and you will get, I'm going to ask you, 2 times 5 is, 2 times 5 is, and you'll tell me 10/6. Then you're going to do it like this, 10 times 1/6, and that's your final answer, okay? Let's do it here, number 7. 2 times 2 is 4/3, which is equal to 4 times 1/3. Okay, that's your final answer. All right, yes, yes, yes. This is where I would say that. Yes, 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 yes. Okay, boys and girls, you finish this up. I will have sent you your, I'm doing this the day before, so I will have sent you your stuff online, and then you know what to do. See you on Zoom. Zoomy, zoom, zoom. All right, bye.